So, hello everyone, whoever has joined. So, welcome to the seventh session of the mathematical method course. So, uh, in this, in this session, we will be covering the properties of Laplace transform mostly. So, before before we start the session, first let's go through the doubt that came last time. Last time one person asked in the assignment, this was the fourth question, and the question was which of the following function is not of the exponential order of 1. So clearly in the question it is mentioned that which is not the exponential order 1. So as we know, e power t, if you take the modulus of that, it will be less than or equal to e power t. So that is of order 1. Similarly, if you take the modulus of e power t sine t, so it will be less than or equal to exponential power t. So this also has order of 1. And if you take t cube and you take the modulus of that, clearly it's not of order 1. And in the fourth option sine 2t, if you take the modulus of that, then that will be less than or equal to e power t. So therefore t cube is not of the exponential order 1. So maybe you have not read the question clearly because it's mentioned which is not, so the answer will be t cube only. So basically t cube doesn't have a exponential order of 1. So this was the doubt that came last time, so I hope it is cleared now. And in the assignment I checked, so answer is right. So maybe you can revisit this problem and try to find out the solution. So okay, let's start with the present session now. So what I will go through, I will go through the different properties of Laplace transform in this problem solving session, and then we will be solving some 10 problems, some good problems which will be using all of these property which I will discuss. So let's start with the first property. So I will be glancing very fast over the properties because this has already been covered in the class. So this will be a kind of review for you all. So first property is the translation properties. So if you are given some function f of t and you know the Laplace transform of that function is just pointer option, and you know the Laplace transform of that function is capital F p, which is some function of p, then the Laplace transformation of e power at times ft will be fp minus a. So basically here you shift the this coefficient p by minus a, therefore it's known as shifting property. So this is the first type of shifting property. Then you also have the second shifting property, which is again if you have some function f of t, then the Laplace transform of that will be fp, which you know, and then you are given some function gt which is defined like this. Then the Laplace transformation of this function gt, which is a function of ft, will be e power minus ap times fp. So these two properties are very useful and we will see later when we solve some problem. So these are just the shifting property of first and second kind. So now the third property, mm, third property is the change of scale property. So if you are given some again function which has a Laplace transformation f of p, then the Laplace transformation of f function, which is now has a factor a times t, will be 1 by a f p by a. So this is again is a useful property to remember. And then same can be done if you ask like what is the inverse Laplace transform. So you just need to take the inverse of that. So inverse Laplace transform of f p by a, it will be a times f at, because a will come here when you take the inverse on both sides. So this is the third property, which is the change of scale property. And again there is a other property which is used when you need to find the Laplace transformation of some higher order derivatives. So suppose here you have some higher order derivative where n denotes the order of this derivative, then you can use this property in order to simplify your Laplace transform, and this can be expanded in this way. Again this is a useful property. and it will be good like if you can remember all these property, and it will be easy to solve the problems. So this is the fourth property which is used to find the Laplace transform of the higher order derivatives. So the next property is if you have some function again f of t, and the Laplace transform of that function is denoted by fp, then the Laplace transformation of this new function, which is ft by t, basically you divide your function by t, is given by the integral of fu du, where fu du is coming from f of p, and this the integration goes from p to infinity. So again, this is a important property, and we will be using this in order to solve the problems. So the next property, which is again very useful property, is used when you have some polynomial in front of your function. So if you know the Laplace transform of this function, which is f of p, then the Laplace transform of some higher power t, which is can be any power t power n times ft, is given by the derivative of that function. So if you have minus 1 power n, where n is the order of this polynomial, and then you have the dn by dpn, uh, then you have the dn by dpn times fp. So again, this is a useful property, and again we will be using this in order to solve some problems. So the next properties are used for to find the just next property is used to when you need to find the Laplace transform of some integrals. So if you have some function f of t, then the Laplace transform of that is given by f of p. Then you can actually use this property in order to find the Laplace transformation of some integral. So the Laplace transform of this integral, which is function 0 to t fu du, will be given by fp by p. Okay, and same goes when you need to find the inverse Laplace transform of that. So you just take the inverse on both the side. So therefore it will be inverse Laplace transform of fp by p is equal to 0 to t fu du. So the next thing which we studied during your lecture is the convolution property, which is suppose you have two function ft gt, and they are defined for t greater than 0, then the convolution of ft and gt can be denoted by f star gt, where star denote the convolution, and the formula to find the convolution is, so you take first function, and then you take the second function t with the argument t minus u du, and you integrate it from 0 to t. So this will give you the convolution of two function, and we will be solving one problem on this where it will be you will see how to find the convolution of two function. Okay, then this was the just a small review regarding the different properties of Laplace transform. So now let's start with some problems, and try to use this property in order to solve them. So let's start with the first problem. So the first problem is you are given this function where you need to find the inverse Laplace transform of 3p plus 5 upon p plus 1 power 4. So here the question is asking that you need to use this property which you have studied, and you need to find the inverse Laplace transform of this function. So let's see how to solve this problem, and please stop me if you feel there is any doubt, or raise your hand. Yeah. So let's go through the solution of that. So basically, you know now, if you take this equation, which is the inverse Laplace transform of 3 plus 5 p plus 5 upon p plus 1 power 4. So here first you can use the linearity property of inverse Laplace transform, right? So you can separate the first and second part from this function. So what you can write, you can bring this 3 outside, and then you can write 3 times Laplace inverse Laplace transform of p upon p plus 1 power 4, right? And similarly you can write like by using the linearity property, you can write it as 5 times inverse Laplace transform of 1 upon p plus 1 power 4. So here if you see, There is no such like a standard form where you can calculate this inverse Laplace transform of this function. But here we can use shifting property, and this shifting property can help it to reduce it to some standard form, and then it's very easy to find the inverse Laplace transform. So let's see how to do that. So using the first shifting property where we started, if there is some function ft, then the Laplace transform of that function is given by f of p, right? And similarly, you can define the inverse Laplace transform of fp plus a is equal to e power minus at times ft. And what is ft? Ft is nothing but the inverse Laplace transform of fp, right? So if you use this property, right? So what you can do using this property on both the this part and this part, you can reduce it in the standard form. So let's see how to do that. So if I compare this and this equation, right, and I need to reduce it on the right hand side. So you see what I need to do. I need, if I subtract just a second. So if I just subtract minus 1 from this, right? So if I put a is equal to minus 1 here, right? So if I put a is equal to minus 1, then what I will have? I will have inverse Laplace transform of fp minus 1 is equal to t uh, e power t, and then it will be inverse Laplace transform of f of p. Okay, so let's do that. So if I use this property, what I will have? I will have 3 here, which is a constant, and then it will be e power minus 1t times inverse Laplace transform of f of p. So basically what you are doing in the equation, you are subtracting this a. Okay, so here this property is valid when you have like a is positive number. So what you can do here, if you subtract p minus 1 from here, right? So if I choose a is equal to minus 1, then what you will have? You will have inverse Laplace transform of p minus 1, because here p will be replaced by p minus 1, and then p plus 1 minus 1 will be p power 4, right? And same property can be used on right hand side. So if I subtract minus 1 from here, what I will have? I will have 1 upon p power 4. I am just using this property, right? And from here what you can see, I can again use the linearity property here. So if I use the linearity property, what I will have? I will have 3 e minus t l inverse 1 upon p cube, right? Because p and p power 4, 1 p will cancel, and similarly this minus 1 part will get subtracted with this guy, because the second part of this is 1 upon p power 4, and here also you have 1 upon p power 4, but here you have 5 as a constant, and here you have 3. So 5 minus 3 will be 2. So you will get this equation if you use this property, right? And now you know like what is how does this function come, p cube? So clearly it comes when you have a function which is of form t square, right? Because let me just show you that. So how does this function will comes? So you are getting p cube in the denominator, right? So basically here s denotes p. So p cube in the Laplace transform of p cube will be 1 upon p cube will be t power. So you have p power 4, right? So basically s power 4. Therefore n is 3, right? So what you will have? You have uh, uh, t cube upon 3 factorial, right? Because I can take this n factorial in the denominator on t power n, and you will get the Laplace transform of p power 4. So let's go to the solution. So here I can write it as this, right? T square, because p cube will be t square, and again p4 will be t cube. Yes. Here, no, you will. So if you expand here, you will get minus 3 upon p power 4, and here you have 5 times inverse Laplace transform of 1 upon p power 4. So 5 minus 3 will be 2 only, right? Got it? So here if you expand this, use the linearity property here, right? So you will have minus 3 times e power minus t inverse Laplace transform of 1 upon p power 4, right? And here you will have 5, factor of 5, here you have factor of 3. So this second part will be just 2. You will left with 5 minus 3 is equal to 2, right? Yeah. So got it? Yeah. So here you can see if you use this property, you can reduce it to some standard form, and from there it's very easy to solve this problem. So I hope this problem is clear, and this is a same type of problem as given in the your assignment also. So if you find that difficult, you can revisit that and solve that problem. So let's move to problem number 2. So here in problem number 2, what you have, you are given some if Laplace transform of some function is given by this, where is you have this function, some function f of p, right? Then what will be the Laplace transform of e power t times f4, where now you have modified the function, where instead of t now you have 4 times t. So clearly if you just think, then you can think like it can be solved by using the scaling property, right? Because scaling property works like that only. So if you are given some function f of t, then the Laplace transform of f of at, right? So that property you can use. So let's go through the solution of that. So you are given L f of t is equal to pi by p times e minus 1 by 4p, which is equal to f of p, right? So now if we use the scaling property, so what does scaling property say? If I now try to find like what is the Laplace transform of f of 4t, now instead of t if I have 4t, then using the scaling property, what it says, 1 by a fp by a, right? So where a is this scaling parameter, so here a is clearly 4, so what you will have, you will have 1 by 4 times fp by 4, right? So now if I substitute, we know f of p is this, so f of p by 4 will be pi by 4p times e minus 1 by p, right? Because if I substitute p by 4, then this 4 will go in the square root, and it will become 16 here. And here p by 4, p, if you replace it by p by 4, then 4 will come in the numerator. So 4 and 16 will give you 4 here. And similarly, if you replace it by p by 4, this 4 and this 4 will get cancelled, and you will get this term. Okay. So now you have what is the Laplace transform of f of 4t, right? So now the question is asking, what will be the Laplace transform of e power t times f of 4t? So clearly you have find the Laplace transform of f4t, right? This function. Now you can again change the use the shifting property. So what is the shifting property? Shifting property said if you want to find the Laplace transform of some function e power at times f for some function, so that will be just you replace, like you shift your parameter p by minus 1, because here a is 1. Okay, so if I use this, then I just need to replace p by p minus 1, and I will get the answer. So the answer to this problem is given by this. So you have pi by 4p minus 1 times e upon 1 minus p. So I hope this question is clear. So in this question, basically we use two properties. One is the scaling property and other is the shifting property. So if you have doubt in this question, you can stop me. Otherwise, we will move to the next problem. So okay, let's move on to the next problem then. So in this question, which is the third question, you need to find the inverse Laplace transform of 1 upon p minus 2 power 5. Okay, 1 upon square root p minus 2 power 5. So if anyone want to guess like which property you will be using in order to solve this, then he or she can answer, or I will go to the solution also. So okay, 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 yeah, okay, great. Yeah, okay, so you got the idea. So let's go through the solution. Okay, so what you have here, you again use the shifting property as he said. So what does in shifting property of inverse Laplace transform say. So if you have some inverse Laplace transform of fp minus a, then it will be e power at L inverse of f of p, right? So if I use the same property here, so basically here a is 2, right? Because p minus a, so I can compare it, so a is 2. So basically if a is 2, then I can use this property. So I will write e power 2t inverse Laplace transform of 1 upon p power 5 square root, right? And this you already know. If you again I can show you the standard form also, but it will be like t 3 by 2 upon gamma function of 5 by 2, 5 by 2, right? Because the gamma function will come in the denominator when you are calculating the Laplace transform of 3 by 2. So you can put the value of gamma function of 5 by 2 and you will get this answer. So I hope this question is again clear. It was a fairly easy one. So you just use the shifting property in this in order to reduce it to some standard form. So if there is no doubt, I can move to next question. Okay. Okay. Let's go to next question then. So next question is, you are given this function. So you have, if inverse Laplace transform of e power minus 3p upon p square minus 6p plus 10 is equal to f of t, then what will be ft is. So here you are given the inverse Laplace transform, you need to find the function. So basically you need to find, if you take the Laplace transform of this function ft, then what function will result into this Laplace transform. Okay, so again you can think like how to solve such problem. So yes. Okay, let's see if this is correct. So let's go through the solution. So again, so let me just first describe which property we are using here. So clearly this is the second shifting property. So what it says, if you have some inverse Laplace transform of f of p is equal to f of t, so this is the inverse Laplace transform, then the inverse Laplace transform of e minus ap times f of p will be ft minus a if t greater than a. So clearly this is the, like what I told you, this is the second shifting property corresponding to the inverse Laplace transform. So again, now if I compare our given equation to this form, right, to this form. So if you compare both of them, just try to compare this part and this part. So clearly you can see the value of a is 3, right? If you just compare them, and the value of f of p will be 1 by p square minus 6p plus 10, right? I hope it's clear. You just need to compare them, right? Now you know from here, like if I use this, f of t is equal to L inverse f of p, right? If I need to find this function from here, what will be this function? This function is nothing but L inverse of f of p, and now f of p is nothing but this function. Okay, so what I need to find, this ft is L inverse of 1 upon p minus 3 square plus 1 square, right? So this is this function corresponding if I use this property, right? So what function I get? I get function ft is equal to e3t sine t, because this is nothing but, if you use the shifting property on the sine function, you will get this type of function. I hope it's clear. It's just the standard form, because sine t is given by a upon uh, p square plus a square. So that will result into sine t. Any, if you use the shifting property on this, this will give you e power 3t. But here the catch is, you are finding the Laplace transform of just f of p and you are getting this function. But the question is asking, if you have the this complete function f of p, then what will be this function f of t? So let's see how to find that. So as you know, like if you have inverse Laplace transform of e minus ap f of p is equal to ft minus a, that is the inverse Laplace transform, then like again you use the shifting property here. So you know the inverse Laplace transform of this just like f of p is given by this, right? So if you add e power minus 3p here, then you again use the shifting property here, right? Right, because you shift your t by t minus 3, because here a is 3 and you get this type of function. So this is the final answer corresponding to this question. So if you have any doubt, you can ask. So here we use the second shifting property and we able to find what will be the this function ft corresponding to the this inverse Laplace transform. So if you have any doubt, please ask or I will move forward. Okay. So this is again the same problem also you can find in your assignment, but this is of slightly different form. Okay. So let's go to the next problem. So here you are given this function and you need to find the Laplace transform of this. So here you have function t e power minus 4t times sine 3t. So any guess of on how to solve this problem? Okay. Okay, and then and t for t also you need. Okay, great. So basically you are using two properties here. So first you just calculate like what is the Laplace transform of sine 3t. So Laplace transform of sine 3t is nothing but 3 upon p square plus 9, right? Because it is a upon p square plus a square. So a here is 3. So you will have 3 upon p square plus 9. Now you use the shifting property. So if I use the shifting property here, L e minus 4t sine 3t. So basically that correspond to I put p plus 4 here, right? Because here it's minus sign, so that will be p plus 4. So if I put p plus 4 whole square plus 9, then I will get this term, right? So now you call this function f of p, and now you use the multiplication property of Laplace transform. So what multiplication property suggests? L of Laplace transform of t power n times some ft is equal to minus 1 times power n, and then you have the dn fp upon dpn, right? So clearly the order of this polynomial is 1. So what I will have minus 1 power 1 into dfp by dp, right? Because here the power of t is 1, so order of the derivative will 1 only. So now what you get? So if you solve here, what you need to take? You need to take the derivative of this, right? And you will get this answer. So here you just need to do the differentiation of dfp by dp and with the minus sign, and you will get your answer. So I hope this question is clear. Again, you just again use the shifting property and the multiplication property of the Laplace transform in order to solve this problem. Okay, so okay, let's move on to the next problem. So again, it's a fairly easy one. So you need to find the Laplace transform of 1 minus cos 3t upon t. Okay, so I hope you already got the answer, like how you will solve this problem. So first you will just solve it for 1 minus cos 3t, and then you use the divide property of the Laplace transform in order to solve that, right? So we know the Laplace transform of 1 minus cos 3t is equal to f of p. So if I now try to find out like what is f of p, f of p will be 1 by p minus p upon p square plus 9, right? Because a Laplace transform of 1 will be 1 by p, and the Laplace transform of cos 3t is equal to p upon p square plus 9. And now you use the divide property of the Laplace transform. So what that property says? So Laplace transform of 1 minus cos 3t upon t will be p to infinity fu du. So basically you replace this function by f of u. So basically if you put replace p by u here, you will get from p to infinity integral 1 by u minus u upon u square plus 9 times du. And if you solve this integral, you will get your answer. So in this problem, we just use the divide property of the Laplace transform in order to solve this problem. So I hope this was a fairly easy one. So let's move to the next problem.
Excuse me, sir.
Yes,
Sir, I'm solving the question number 8 and 9 in assignment number 7.
assignment number 7. Uh,
Okay.
this is but I am going through the week 6 right now. So next week I will be going through that assignment actually.
Yes, sir.
Yes, options are wrong.
Uh, yes, yes, sir. Answers are not match.
Oh, I have not actually
Not
seen that. I will maybe clear that in the next class, but I will see what I
but sir,
can.
tomorrow is the last date to submit.
Oh, so you don't have any official email to. Maybe what I will do, I will email to the committee today that. So what problem you are seeing? I will write that. So problem number seven, assignment number seven, eight and nine problem.
8 and 9.
Okay, okay.
Yes,
I
sir.
I will
8 and 9.
convey them and convey this message to them and see what result I get. I will convey you to. Okay, okay,
Nice, sir. Nice.
okay. Thank you. So let's go to the next problem. So here you are given some function ln of p plus 3 upon p plus 2 and you need to find the inverse Laplace transform of that. Okay. So so what you have, how to solve this problem? So anybody want to guess like how you will solve this problem where you have, yes,
Yes, sir. Yes, sir.
hello, okay,
Sir, we use the derivative property.
derivative property here.
Yes, sir. Firstly, upon the log p plus 3 minus log p plus 2, and then differentiate this. Then it becomes 1 upon p plus 3 minus 1 upon p plus 2.
Right, right.
And thereafter, we take the log of derivative Laplace inverse Laplace transform of derivatives.
Oh, okay.
So left hand side becomes f dash p inverse Laplace is minus tft.
Oh, great, great. And from there you can calculate f of t. Okay,
Yes, sir.
great, great. Okay, let's go through the solution. You already know the answer. So as you suggest, what we do first, we call it some function f of t because this will give you some function which is a function of t. And then from there, what you are doing, you are denoting this function by f of p because you are saying the inverse Laplace transform of f of p is equal to f of t. So f of p you can write like this, which is ln p plus 3 minus ln p plus 2, right? And then you can use the this so you can use this property which is L of TFT, which is given by minus dfp by dp, right? And from there you can take the inverse Laplace transform of that. So what you will have, you will have ft is equal to minus times inverse Laplace transform of 1 by t times dfp by dp, right? And then it's very easy to solve. So basically you just take the derivative of f of p and then you just take the inverse Laplace transform of that. So we know that 1 upon p plus 3 will give you e power minus 2t and here you will get e power minus 3t and you just divide it by t. So this was also like here you use the different property which is the derivative property in order to solve the problem. You already answered it, so I hope there is no doubt in that. So let's move on to the next problem. So here again you are given some function which is t square integration of 0 to t e power minus 5u du and you need to find the Laplace transform of that. So okay, let's go through the solution of this. So here you will be using for sure you will be using integrating property and then you need to use the polynomial property of multiplication. So let's go through the answer. So suppose I am calling this function ft e power minus 5t. Okay, suppose you have some function ft which is given by e power minus 5t, and if I take the Laplace transform of that, so l times ft will be f of p, right? Because and you know what will be f of p, so the Laplace transform of e power minus 5t will given by 1 upon p plus 5, right? Because the Laplace transform of e power minus 5t is 1 upon p plus 5. Now you also know, like if you take the Laplace transform of this thing where I am using this property, so Laplace transform of this fu du integration 0 to t is given by fp over p, right? Using this property. and also you know like what is the Laplace transform of f of t. So then you can ask like what will be the Laplace transform of some t square times some function. So if you compare this part with this part, so you can say n here is 2 and f of t is given by integration of 0 to t e power minus 5u du, right? So what it is saying, so here fp is what? Fp is the Laplace transform of this function ft, right? So here what you need to do, you need to use this property. So here n is 2, so what you will have, you will have minus 1 power 2 and then double derivative of fp. So what is fp here? So fp here is nothing but the Laplace transform of this function, and the Laplace your final function fp which is coming here will be 1 upon p times p plus 5, right? So you will have this function here, and then you take the double derivative of this. So basically if you take the double derivative of this, you will get this type of function. So basically the answer of this problem is given by 2 times 3p square plus 15p plus 25 upon p cube plus p plus 5 ka whole cube. So here you use basically two properties, which is this integration property and this is the multiplication property, in order to solve this problem. So I hope this problem is clear, right? Okay, let's move on to the next problem then. So here this is the second last problem. So here you are given two function, which is e power minus 2t and sine t, and you need to find like what are the convolution of this. So according to the convolution formula, what you have, first you write first function which is f of u, then you write second function which is g of t minus u, right? So f of u here will be e power minus 2u and g of t minus u will be sine t minus u du, right? So now the final thing is you need to integrate this, right? So how to do the integration of this? So first you use the by parts, integration by parts. So you take this as function as first and you take this function as second, so you will get this result. So e power minus 2u will be as it is, and the integration of sine t minus u will be like this from 0 to t, and then you take the derivative of this e power minus 2u and again you do the integration according to the by parts formula, you will get this equation, right? So now you need to solve this integral, right? So what you will have, if you solve this definite integral part, you will get e power minus 2t minus cos t plus again you use the by parts in this, right? So you can again use the by parts in this by taking this function as first and this function as second. So again you use the by part here. So if you see after doing the second integration by parts, you will see that what I can do, the question is asking me to calculate this integral, right? So what I can do, I can bring this right hand side part on the left hand side. So what I will get, I will get a factor of 5 here because this has minus sign, so when it goes here it will be like plus 5, right? And from there you can easily calculate like what will be the convolution of these two functions. So here you get factor of 1 by 5 because 4 plus 1 will be 5, and here you just need to put the limits in this to get this numerator. So I hope this question is again clear, and this was a very easy one, and here you just need to find the convolution of two functions. So okay, let's move on to the last problem of this. So last problem is basically you need to calculate this integral. So what will be the value of this integral? So anybody want to answer, like want to solve or like how to?
Yes, sir, I can answer.
Yes. Okay.
No, sir, first we can.
So anyone can answer actually.
Uh,
Yes.
Sir, first we take the Laplace transform of sin t
Okay.
and then use the multiple property with t square.
Okay.
First, first we take the Laplace transform of sin t
Yes.
and then using the multiplication property of t square,
Right. Right.
then we get the Laplace transform of t square sin t.
Okay.
And Laplace transform of t square sin t becomes 0 to infinity e raised to power minus pt
Right.
and t square sin t dt.
Right. Right.
Right, sir?
Right.
And then after we put the limit of p tends to 3.
Right.
then we get the answer.
Right, great. So you already know the answer. So let's go through the solution of this. So as you said, first you use ft is equal to sin t, and you do the Laplace transform of that, which will be 1 upon p square plus 1. And then you do the use the multiplication property of Laplace transform, which is t square sin t is equal to minus 1 square d square by dp square upon p 1 upon p square plus 1. So from here you what you get Laplace transform of t square sin t, right? And this Laplace transform you can also write in this form. So you can write it as 0 to infinity e power minus pt t square sin t dt. And from there what you can do, as you said, you can put the value of p approaches to 3 and you can get this integral, which is 13 upon 250. So I hope you got the idea, like how to solve such problem. So this was all about this problem solving session. So uh, so